Hey guys, converting repeating decimals to fractions. Now I wasn't gonna make this video right now, but someone named Marsha wanted me to make it. And I said, well, why not? Listen, when someone has an inquiring mind, you want to feed it, feed it, feed it. Now I don't know how good I can feed it. It might be a Burger King instead of like a Longhorn Steakhouse, but I'm gonna give it a try. Repeating decimals. You ever seen one of them? 0.99. And it just, what that means is it goes on forever. Okay? And so how do we convert that to a fraction? Well, I hope you realize that a fraction is all it is a dividing question. 3 divided by 8, okay? All right, so what we're gonna do is we're gonna start looking at some stuff and seeing if we can pick it up some patterns. Now, I know you guys think I'm a math teacher, but I've never taught a math class in my life. I'm a social studies teacher. I teach history, economics. Yes, that might surprise you, but here is something we can do in math. We can look for patterns and sequences and things that keep popping up, and that's what we do in history. So let's go. Let's start right now. All right, so let's take a look at some simple fractions and look at the decimal form of that simple fraction and see if we can pick up on any kind of patterns. Let's start with 1/10. 1/10 equals 0.1. All right, let's go with 1/9. All right, 1/9 is going to be 0.1 to infinity. It's going to keep going and going and going forever. Okay, let's do 1/8. 1/8 in decimal form is going to be 0.125. Okay, I'll make sure I'm still on the screen here. 1/7. Now that's an ugly one. I'm going to have to look down here at that. That's going to be 0.142857. We're looking for patterns. Let's go 1/6. All right, 1/6 is going to be something interesting here. And the 6 keeps going. Okay, so 0.166666. So I put a line over it, but we could just go. Remember now, if the line went over both of them, it'd be 0.16, 16, 16. But I only put it over the 6, so that means the 6 just keeps going. So that's something interesting. Okay, let's take a look at 1/5. I'm not gonna cut myself off here. I think I can get one more down here. 1/5 we know is 0.2. Okay, now let's go up here and do 1/4. Okay, 0.25, 1/3. 1/3 is 0.33, and then 1/2 is 0.5. All right, so let's take a look at these right here. How you doing, Marshall? All right, so right off the bat, I see this one is a potential 1/9. I see this is repeating 1/6 and 1/3. The rest of them do not repeat. Okay, so let's just get rid of all the chaff here. And let's just. All right, now let's take a look at these 3 and let's narrow it down even more. Okay. Well, right off the bat, what I see here is there is actually a 1 here that does not repeat. It's the 6 that repeats, so 0.166666. So since the 1 does not repeat, I'm going to get rid of this one. And we're down to 2 of them. Okay? And I'll just fix this right quick. Okay? And that's Okay, so 1/9 is 0.1 repeater, and 1/3 is 0.3 repeater. Do you see something that I've noticed? Look at this. 1/3 can be expressed in ninths. All I would have to do is multiply by 3/3, okay? So, since this can be, we can speak in terms of ninth through 1/3, and since 0.1 repeater, ones are a pretty easy number, right? Let's just eliminate this one. And now let's look at 1/9 or 0.1 repeater, okay? Now let's take a look at 1/9, and then let's look at some other repeating decimals and see if we can use 1/9 to understand. Let's take 5/9, okay? Now, 5/9 is 1/9 plus 1/9 plus 1/9 plus 1/9, right? Plus 1/9, right? Because we know that we keep the denominator and we just add the tops. 1, 2, 3, 4, 5, right? Make sure that, okay. All right, so another way of writing that is 1/9 times 5. Would you agree with that? Okay, because see, 5 is really 5/1, and we know in multiplication of fractions, we take the numerators, 1 times 5 is 5, and the bottoms, the denominator, 9 times 1 is 9, okay? Now let's take a look at that. 5/9. Okay, so right here, 1/9 equals 0.1 repeater. So, let me put that in purple here. 0.1 repeater times 5. Check that out. Isn't this the same as this? Okay? Take a look at this. 1/9 times 5. 1/9 in the form of a decimal is 0.1 repeater times 5. Okay? So let's do that. Let's add this multiplication problem right here. Take a look. Okay? We know that if we went 0.11111, well, we never could finish it out because it just goes indefinitely, times 5 would be 5 times 1, 5 times 1, 5 times 1, and it would be 0.5 repeater. Right? All right, so it looks like when I have a decimal repeating that I can express it in ninths. Let's look at 0.7 repeater. Okay? So what is that? Okay? So isn't that 7 times 0.1 repeater? Point 7 repeater is 7 times 0.1 repeater, because remember 0.1 repeater would just be 7, 7, 7, 7, so it would be 0.7 repeater, same thing, right? Okay, and so let's go backwards, okay? And so that means that since 7 times 0.1 repeater is 1/9, can't we say 7 times, I'm just taking this decimal and putting it in the form of a fraction, 1/9. 7 times 1/9 equals 7/9, right? You know 7 is the same thing as 7 over 1. 7 ninths. So, does that hold true with everything? Well, let's take a look. Okay? Are we starting to see something here? Okay? Let's keep going now. Just because we seem lucky, we start to see a little bit. We don't want to get ahead of ourselves, because like in English, there's always exceptions to the rule. Okay, so let's look at. I'm liking the ninths. Okay, I feel comfortable with it. So let's look at 1 over 99 and see if we can do the same things we did with the ninth. Okay, so 1/99 is 0.010101. Okay, and so we know that we can just simplify that and say it's a 0.1 repeater. Okay, 1/99 equals 0.01 repeater. So what if we had 12/99? Okay, 12/99. Well, isn't that the same as saying 12 times 1 over 99? Isn't that the same thing? So what is that? Isn't that 12 times, I'm converting, 0.01 repeaters? Okay? I'm taking this and I'm just converting it to that. Okay? Now, I didn't finish this problem out, but 12 times 0.01 is what? Is going to get you 0.12 repeater. Okay? Alright, so let's take a look at another one, okay? But we're going backwards this time, okay? So 0.52 repeater. Okay? So 0.52 repeater is the same as 52 times 0.01 repeater. Okay? So, what would that be? Well, that's 52 times 1 over 99. I just converted this into that, because that's what we said up here. Okay? Remember now. So, let's go ahead and answer this. 52 times 199 is 52 over 99. This pattern holds true. The 1/9 and the 199 holds true no matter what. It's always going to work out. So a repeating 2 decimal can be expressed with the number over 99. Okay? Always holds true. So let's wrap this up with just a few things that could run you off the road. You're taking your test, you think you know it, and then boom, you hit something. Alright? Alright, so let's erase this for a minute. And let's just look at something that we need to be aware of. Okay? So first of all, we're recognizing here that when I have 2 digits repeating, that all I'm going to do is put the number and then count the places. 1, 2. Okay? And that gives me. So, 2 decimal repeater. What did I do wrong? Ah, you caught it. It's not over 100. It's over 99. Because, why? Once again, over repeater, right? 75 times 1 over 99. So 75 over 99. Will you following me? Marcia, what's up? Alright, here are the pitfalls of it. Let's take a look at this number. only 2 of the digits repeat. So we have to use a little different rule here, okay? That is not going to be over 99. So since that is something different, we can talk about that in another video, okay? So if only 2 of the digits repeat, it's not going to work. What we're doing in this video is not going to work. Now what about this? Let me see now. I want to make sure. .47 repeat. Well, yes, the digits to the right of the decimal do repeat. 2.57, 2.47. This is a whole number though. So what we can do is we can still express this, but we have to put the 2 down. And then we take the 2 numbers on the numerator over 99. Okay? You gotta make sure. Okay, we can't get too fast, can't get too ahead of us. So, repeating decimals or repeater decimals and how we can convert them to fractions easily, because we're usually test or time. All right, I hope you enjoyed this video. Thanks for watching.